Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here, and in this video we are going to be looking at the unit circle. So by the end of this lesson, you'll be able to do these two things. Explain the unit circle definition of sine theta, cos theta, and tan theta, and use the unit circle to find exact values of them in both degrees and radians for integer multiples of pi on 6 and pi on 4. So let's have a look at the unit circle definition. So here we have a unit circle, and in a unit circle, the radius is 1. Okay, and because we have unit, we know unit means 1. The coordinates of a point is useful in determining what sine theta, cos theta, and tan theta are equal to. So let's have a look at this. For example, if we take a point here, we'll call it point P, and we construct a right angle triangle from the center of the circle. Here's our right angle triangle. We know that the radius is 1. However, what we don't know is what this is and what this is. Okay, so if we want to work out the sides, the length of the sides of this right angle triangle, this side here that I've highlighted in yellow has to be of length y. Okay? And this side here that I've highlighted in orange has to be of length x. That means that this point here is x, y. So if I want to find sine of the angle theta, so we have theta here, and we want to find sine of that angle. We know sine is equal to opposite over hypotenuse. Opposite is y, hypotenuse is 1. And so y divided by 1 is just y. If we have cos of theta is equal to adjacent over hypotenuse, adjacent to the angle is x, hypotenuse is 1, and x divided by 1 is just x. For tan theta, we know tan is equal to opposite over adjacent. Opposite of the angle is y, and adjacent to the angle is x. So we have tan theta is equal to y on x. Now it's very important that you memorize these, particularly the first two. So I'm just going to write here, sine of theta is equal to y, cos of theta is equal to x. Okay, so it's very important that you memorize these. How I memorize this is that I know that it's not cozy, so it's not cos is equal to y, so it's not cozy, so it has to be sine y. Sine of the angle has to equal to y, and cos of the angle has to equal to x. And I know that tan is equal to sine on cos. And if it's not cozy, then it has to be x at the bottom, and sine has to be at the top, y. So tan of the angle is y on x. Okay, so that's how I memorize these. So the coordinates is very useful because this x here, we can rewrite this point as cos theta, sine theta. Okay, so if I want to work out what is sine of 50 degrees, then all I need to do is look at the y value of the coordinate. Whereas if the question asks what is cos of 50 degrees, then I would look at the x value of the coordinate. Okay, so cos theta, sine theta, nice and easy, is in alphabetical order. Like x and y is alphabetical order, cos comes before sine. Alright. So now we're going to have a look at the second part of this video, which is how to use the unit circle to find exact values. Now, what I'm going to share with you, I really want you to memorize. Okay, I really want you to memorize how to construct this unit circle. Like I said, coordinates are very important. So maybe before we start off with coordinates, let's have a look at the angles. So we know that this is 0 degrees. This is 30, 45, 60, which we can rewrite as pi on 6, pi on 4, and pi on 3 if we want it in radians instead of degrees. Okay. So in order for us to memorize this in exact values, what I'm going to do is we're going to write our coordinates for each of these points. It's important to remember that they all are fractions over 2. So we just start off with writing all over 2. The next thing we need to do is write 1, 2, 3, and then the same thing but the opposite way. 1, 2, 3. And then we are going to square root every single numerator. The square root of 1 is just 1, so we can just leave it like that. We've got root 3. We've got root 2, root 2, root 3, and the square root of 1 is just 1. Okay, and that's it for this section. What we need to know now, because we've done that, we can fill out the rest of this unit circle. So the only thing that I really want you to memorize is this bit here. Once you've done that, you should be able to fill out the rest of this unit circle. So we know that this bit here is 30 degrees more than 90 degrees. Okay, actually let me write 90 degrees down here. Therefore this is 120. Whoops. This bit here is 45 degrees more than 90. So this is what's 135. And this is 150. 180. And I'm just going to fill out the rest of this. 210, 225, 240, 270, 300, 315, and 330. So I've done it in degrees. Now I'm going to do it in radians. So we've got pi on 2, 2 pi on 3. And you should already know how to convert between degrees and radians. 3 pi on 4, 5 pi on 6 pi, 7 pi on 6, 5 pi on 4, 4 pi on 3, 3 pi on 2, 5 pi on 3, 7 pi on 4, and 11 pi on 6. So for example, in case you've forgotten what to do, how to convert these, you just take the angle, the degrees. So let's say we took 150 degrees. All you have to do is divide that by 180. And then write it as a fraction. So it's 5 pi on 6. And that's what we've got here. Okay. If we wanted to take 330 degrees, just divide it by 180. Put it as a fraction. It's going to be 11 pi on 6. Okay. So now we fill that all out. What we need are the coordinates, because the coordinates tell us what sine theta, cos theta, and tan theta are equal to. Okay, so we know that this point here corresponds exactly with this point. So I'm going to write exactly the same thing on the other side. We've got root 3 on 2 half. Except what we notice is that on the left-hand side of the y-axis, x is negative, which means I need to put a negative sign in front of the x coordinate. And that's going to be the same thing for all of them. Okay, we know that it's still above the x-axis, therefore the y's must be positive. So I'm leaving half as positive. So I'm just going to rewrite the rest of these. We've got root 2 on 2, root 2 on 2, half, root 3 on 2. However, like I said, all the x coordinates, all the x values are negative. So I'm going to have to write a negative in front of them. Okay. This one here corresponds with this. Okay, so it's like a mirror image, you can say, a reflection. If you want to say, you can say that it corresponds with this one. Okay, so we're just going to write it in reverse now. We've got root 3 on 2, half, root 2 on 2, root 2 on 2, half, root 3 on 2. The question is, what's negative and what's positive? Well, it seems like they are both negative, because on this side of the y-axis, x is negative, and on this side of the x-axis, y is negative. So they are both negative. Let's just get a little bit more obvious. Okay. And we can do the same thing for this one. We can say that this is a reflection of that. Okay, it's just a mirror image. So I'm just going to write exactly the same thing, root 3 on 2, without the minus signs. Half, root 2 on 2, root 2 on 2. And half, root 3 on 2. Except here, x is positive and y is negative. So that means all the y coordinates are going to be negative. Okay. So I really want you to memorize how to construct this, because in an exam you might be asked to find the exact value of any of these. And I'll go through some examples. And if you know how to construct this, it's going to make your life a lot easier. So it's important to remember that these coordinates is cos of the angle first, then sine of the angle. Okay, so it's in alphabetical order, cos then sine, like x then y. Or you can think about it's not cosy. Okay, it's not cos is y, cos has to be x. So sine of 45. So here's my 45-degree angle. Right, it's one of these. But because it's sine, sine is this one. So sine of 45 is equal to root 2 on 2. Okay. What about cos of 2 pi on 3? Okay, so now all we need to do is locate where is 2 pi on 3. 2 pi on 3 is here. So it has to be one of these. Because it's cos is the first number, so the answer is negative half. Okay, Let's have a look at C. Tan of 7 pi on 6. Well, 7 pi on 6 is here. But because it's tan, and we know tan is sine theta on cos theta, sine of the angle on cos of the angle, sine is negative half, cos is negative root 3 and 2. The 2's cancel, the negatives cancel, so I'm left with 1 over root 3. Okay. Have a go with questions D, E, and F. I'll get you to pause the video, and when you're ready, continue playing the video to check the answers. Okay, so question D, cos of 300 degrees. So we're going to look for 300 degrees, which is here. So cos is the first one, okay, alphabetical order, so it's just equal to half. Sine of 11 pi on 6, 11 pi on 6 is here, sine is the second one, so it's equal to negative half. Tan of 150, 150 is here. So we need to use all of this because we know tan is sine on cos. And sine of 150 is half. Cos of 150 is negative root 3 and 2. 2's cancel. So I'm left with negative 1 over root 3. Okay, so now you know how to explain the unit circle definition of sine, cos, and tan. And you also know how to use the unit circle to find the exact values of sine, cos, and tan in both degrees and radians for integer multiples of pi on 6 and pi on 4. Remember, it's very important for you to learn how to memorize how to construct the unit circle for exact values. And that's it for this video.